Okay, let's get started. So the clip for this lapel microphone is missing, so I'm going to have to hold it up to my mouth if you're wondering what's going on. So the topic of today's lecture is creating and using objects. Okay, so now we've talked about the primitive types and strings in Java. And it's entirely possible to write even a very sophisticated program in Java using only the primitive types, but that's not normally what happens. Right? So almost every non-trivial program in Java will make extensive use of objects, and these objects interact with one another. Okay? Now, why use objects? It's because objects can perform more operations than the primitive values. Right? So if you really wanted to, you could write more or less any program you can think of using just the primitive types in Java. It would be very hard, but you could do it, right? Because at the end of the day, your computer program's just numbers. It's just bits and bytes, right? So you can, in fact, with a lot of effort, write a program using only the primitive types. But no one wants to do that, right? So instead, we use these things called objects. Now the reason, so the structure of an object, every object has information. Right? So an object carries information with it stored in its own variables. Right? So with every object that you have, it's got its own pieces of information. Right? So these variables are called fields or instance variables in Java. Now the fields, they can be primitive types and they can be reference types. So what does that mean? Right? So that means an object can be made up of other objects. Right? And those objects can be made up of other objects. And those objects can be made up of other objects, and so on, and so on, and so on. Right? And so you can layer this complexity very easily if you use objects. So the set of values of an object's field, it's what we call the state of an object. Right? So if an object has, say, two int values, right, and their values are 1 and 2, we say that the state of the object are the two int values 1 and 2. Right? So it's just the values of the fields. Now, so an object also has behavior. So that means there are operations that you can perform with objects. Right? So with int, so with the primitive types, like the primitive numeric types, you know you can do things like add, subtract, divide, and things like that. Right? With objects, you can define what their behavior is. Right? And so the way you define what their behavior is to define methods for the objects. Right? If someone supplies you with objects, then they've already supplied you with the methods that those objects can use. Right? So the way that objects interact with one another is that they call methods on other objects. Right? So if two objects know about each other, then they can call the methods belonging to the other object. Right? And that's how an object-oriented program is constructed. You've got a bunch of objects that are all communicating with one another. Okay, so before you can use an object in your program, right, you have to create it. Right? So we say that an object is born. Right? Then you go ahead and use the object once it's been created, right? And then when you no longer need the object can be destroyed, right? So created means memory is allocated for the object and the state of the object is initialized, right? Destroyed means that whatever resources were used by the object, they can now be freed back to the Java runtime. Right? So if an object uses up a lot of memory, when you're done with it, you can the memory used by the object can be released back to the Java virtual machine. Right? Now in Java, you have control over 1 and 2. Right? So you have control over when an object is created and how it's created, and you have control over how the object is used. Right? What you don't have control of is over number 3. Right? So Java has something called a garbage collector that takes care of getting rid of objects when they're no longer needed. Right? So the details of which aren't important right now. Right? That's actually that was one of the big changes that Java made compared to C, right? The language that, C and C++, so the two languages that were dominant at the time Java came into being. Right? Those other two languages, they forced the programmer to control the destruction of things, right? In the program. Right? So if a C program allocates memory, the programmer must deallocate the memory as well. Right? If you don't, then your program ends up using more and more and more memory, potentially causing you to run out of memory and the program to crash. Right, so Java automates that process, or tries to automate that process. Okay, so how do you create an object? You use something called the new operator, right? And so you've seen this with the arrays already, right? You've seen when we make an array, it's something like int square brackets x equals new, right? Int square brackets, right? So you've already seen the new operator. That operator is responsible for three things, right? So it allocates memory for the new object, right? So every object occupies some amount of memory, right? The new operator is the thing that's responsible for allocating that memory. The second thing that new does is it calls what's called a constructor to initialize the state of the new object, right? So you created, say, a new string, right? A string constructor runs that fills in the characters of the string. Right? So a string constructor says this string represents the characters HELLO, for example. Right? And then the new operator returns a reference to the new object, right? So that the caller can store that reference in a variable, and now when they use that variable, they can use the object that was just created. So here are some examples using this class called point2. And this class point2 is from the course notebooks. So you have access to all this source code, right? If you grab the notes, there's an Eclipse project sitting in the notes, and if you import that project, you've got all of the source code for the course. So this point2 object, it just represents a two-dimensional point, right? Now, if you're going to use this thing, you have to import it, right? So notice that it's in a very complicated package structure, but that's just to keep everything organized, right? So how do you allocate a new point? Well, you use the new operator, right? Hang on, let me pull up this thing. Right, you use the new operator. Right, so you use new, and then new is always followed by what's called a constructor call, right? So if you want to make a point2 object, it's always new point2 blah something, right? Something inside round brackets. And that constructor call, it looks like a method call. Okay, now once you're done with that, right, so once you write new point2, new returns a reference to that newly created point2 object. So you can store that reference in a variable, right, p1 of type point2. Right? And so that's what that line is doing, right? That actually causes a lot of things to happen, right? Memory gets allocated, object gets initialized, a reference to the object gets returned back to the caller. So if you have no arguments inside the round bracket, you get the point 0, 0. Right? If you specify two coordinates, right, that lets the caller set the coordinates of the point. So now you get the point 1, 0.5. And the third one is an example of what's called a copy constructor. So that will copy an existing object and so it'll copy the state of the existing object and set the state of the object referred to by point 3, by P3, to the same state as the object referred to by P2. Right? So all this line is doing is copying the point that's on the second line. Right? So now the 2 points have the same coordinates. Now the important thing here to note is that these 3 points, they're all independent. Right? So P1, P2, P3, right? There's 3 calls to new, right? New, new, new. So that means you know there are 3.2 objects kicking around in memory at this point in time, right? And they're all independent. So if you do something with P1, right? For example, if you print P1, or if you change the coordinates of P1, that's better. Right? If you change the coordinates of P1, P2 and P3, those coordinates don't change. Right? They're all independent. They all have their own state. Right? Let's see. So I'm going to run there. So that's an example of making the 3 points. I'm not going to do anything with them. I'm just going to print them out, right? So that you can see that in fact, right, you do in fact get the points 0, 0, 1, 1.5, and 1.5, right? And there really are 3 different points in memory. Okay. Here's an example of using this class called scanner. Right? So scanner is the thing that you use if you want to read keyboard input. Right? So if you want to write a program where you're prompting the user for input, right, you use something called the scanner. Right? How do you make a scanner? Well, you say new, right? The type is big S scanner, so you write new scanner, right? And then you call so that's calling a constructor, right? You need to know something about what constructors a class has, right, in order to know how to call them. In this case, I pass in system.in. So system.in is something called the standard input stream. Standard input stream is connected to your keyboard. So this is just a scanner that's going to read your keyboard, right? So that makes a scanner S1. Right? I can make a scanner S2, right, that instead of being connected to a keyboard, I can connect the scanner to a string. Right? So I can connect the scanner to the string one fish, two fish, red fish, blue fish. Right? And then you can use the scanner to separate that string into its individual parts. Right? So for example, you're able to use the scanner to get the 1, the first fish, the 2, the second fish, the red, the third fish, and so on and so on. Right? So the scanner class has methods that let you extract parts of the string. Right? So that can be, you can imagine that could be very useful. Okay, so now, when you want to make an object, you're always using the new operator. Well, okay, so when you want to make an object yourself, you're almost always using the new operator. Sometimes you'll call a method, right? And the method will return an object. Right? But inside that method, whoever wrote that method, they're calling new, right? Or they will eventually call new. Right? That's almost exactly true, but it's not quite. But it's close enough for our purposes. Right? So new is the way that you normally create an object. Right? It's always followed by a constructor call. Right? That constructor call looks a lot like a method call. Okay? And it confuses most programmers to Java. Right? You say, well, it's just calling a constructor. Right? The way I call the constructor is exactly like calling a method. But the Java language standard says constructors are not methods. Right? So there is a difference between a constructor and a method. Right? The one difference in particular is that a constructor never returns a value. Right? So it never returns a value, not even void. Right? So you'll see later on in a week or so, when we start to write our own constructors, you'll see that when you define the constructor, there's no return type on the constructor. There's a second thing you need to know about constructors. You can't call them unless you use new. Right? So there's no way to call a constructor without using new as well. Okay? So it's not, constructors are different than methods. Okay, so where are these constructors defined? Well, they're defined inside classes. And remember, the classes define these reference types. Right? So somewhere inside the point2 class, there's a point2 constructor. Somewhere inside the scanner class, there's a scanner constructor. Right? The rule of the constructor, of naming constructors, is that the name of the constructor always matches the name of the class. Right? So when you want to make a scanner object, you always write new scanner. Right? When you want to make a point2 object, you always write new point2. Right? So you can't give the constructors a different name. Right? Now, why are you calling these constructors? Right? So new already allocates the memory for the object. Right? So what's the constructor doing? The constructor is going in and filling in the information for the object. Right? So it initializes the state of the newly created object. Right? A good constructor will initialize the state so that the object has a valid state. Right? So for example, if you have a class that represents the time of day, right? A well-written constructor will never give you a negative time of day. Right? Or a time of day that says that the hour is 37 or something like that. Right? Okay, now there's a few different types of constructors. Well, there's really two special types of constructors, and then there's everything else. Okay? So the point2 example shows you examples of all three types of interesting constructors. Right? So there's something called the no argument constructor. Right? The no argument constructor, it describes exactly what it is, right? It's the constructor that you call with no arguments, right? So when you write new point2 round bracket, right, with nothing inside the round brackets, you're calling the no argument constructor. It's sometimes called the default constructor, but its correct name is the no argument constructor. Right, so when do you call the no argument constructor? When you don't really care what the initial state of the object is. Right? So the no argument constructor creates, initializes an object and sets its state to some well-defined default state. Right? So whoever created the constructor will tell you when you call this constructor, the state of the object will be blah. Right? So they will tell you what the state of the object is. Right? For the point2 class, the documentation for the constructor says, for the no argument constructor says that it'll give you back the point 0, 0. Right? So whenever you say new point 2, round bracket, you always get back a new point 2 object whose coordinates are 0, 0. Right? Now, a class does not need to define a no argument constructor. Right? So not every class has one of these, and you'll have to look up the documentation to find out if one exists. And we'll do that in a minute. Okay, the second type of interesting constructor is what's called the copy constructor. Okay? So a copy constructor is a constructor that has exactly one input. Right? That input, the type of that input is the same as the class that you're trying to construct. Right? So in other words, the point2 copy constructor has exactly one argument, has exactly one parameter. Right? The type of that parameter is another point2 object. Right? So what is this thing that you do? Well, it lets you copy another object, and that's why it's called a copy constructor. Right? So the purpose of the copy constructor is to initialize a newly created object by copying the state of another existing object. Right? So P2 is the point 1, 0.5. Right? P3 uses a copy constructor to make a new point and copy the coordinates of point P2. Right? So now you have 2 points whose coordinates are 1 and 0.5. Right? But they're independent. Right? So if you do something with P2 to change its coordinates, P3 is still 1.5. Right? If you do something with P3 to change its coordinates, P2 is still 1.5. Right? They're independent objects. Oh, wait, that's a typo. Not every class defines a copy constructor. So once again, it's your responsibility to look at the documentation of a class and check if there is a copy constructor. Now, besides the no argument and the copy constructor, a class can define as many other constructors as it wants, right? And it depends on how complicated the object is. Normally, it depends on how complicated the object is and how many constructors you'll have. Right? Point 2 is not very complicated, right? It's got an x and a y coordinate. Right? So you can imagine that the point 2 class supplies a constructor that lets the caller set the coordinates of the point. Right? That seems like a sensible thing to do if you're the creator of the point 2 class. Right? So it defines a 2 argument constructor. Right? In this case, it defines a constructor that has 2 doubles. Right? That lets the caller set the coordinates of the set the initial coordinates of the point. Right? And you can define as many other constructors as you want, limited by some rules for defining constructors. But we'll get to that later on. Right? But you need to know right now that a class potentially has many constructors. So the scanner class, there's an example of a class that's got several constructors. Actually, it has quite a few, actually. Right? So the one here, right, the first one, that's a constructor that lets the caller scan the keyboard for input. Right? So here you have to pass in what's called an input stream object. Right? Here, there's a second one. Right? There's a second constructor where you can pass in a string object, and you can have the scanner that's created scan that string. Right? Okay, so once you've created an object, right? So you've created an object by calling new, you've stored the reference back in a variable somewhere, you can now use it. Right? So once you've created the object, you can now use the object via a reference to the object. Right? Via a reference to the object. Now that's the interesting thing in Java. Right? In Java, there's no way for the programmer to get direct access to an object. Right? So there's no way for the programmer to go into memory somewhere, find where the object is living in memory, and use the object that way. Right? In Java, you always use it indirectly via a reference. Right? It's the same is true in Python. And so using an object, usually what that means is that you're going to call a method belonging to the object. Right? That's usually what it means. You can do one other thing, but normally with objects, you're calling methods. Right? And so the way you call the method is you use the dot operator. Right there. How does it work? Well, you've got a reference to the object. Right? So you write the variable name, the reference variable name, dot, method name, and then you pass in however many arguments you need to call the method. Right, so here's a little example. I'm going to make a point. Right? I'm going to get its coordinates. Then I'm going to change its coordinates. Right, so here's my point. Right? So I make the point 0.5, 0.1. Right? I can ask the point. Right? When I write p dot x round bracket, I'm asking the point for its x coordinate. Right? So, hey, point p, what is your x coordinate? Right? And p, that method returns 0.5. Right? Which makes sense, right? Because the x coordinate of this point, 0.5. Right? There's a similar method that lets you get the y coordinate of the point. Right? So p dot y round bracket, that gives you back the coordinate 0.1. So now that I've got x and y, I can go ahead and change them if I like. Right? So I can add 0.1 to x. I can subtract 0.1 from y. And then I can tell p to change its coordinates to x and y. Right? So p dot x, round bracket x, or any other double value, will change the coordinates to the specified value. Right? So that changes the coordinates of x to, of p. That changes the x coordinate of p to 0.6 in this case. Right? P dot y changes the y coordinate to 0 in this case. Right? And if you wanted to, you can change them both at once with this method called set. So p dot set xy changes the coordinates, changes both the x and y coordinates in the same method. Right? So make the object, call some methods on the object, right, to do whatever it is you need to do. Here's a more sophisticated example using point 2. Now, I say more sophisticated, but it's really not very complicated. Right? So, starting on line 1, right, I make a point. Its coordinates are 0.5 and 0.5. Right? Now, what I'm going to do is I'm going to draw this point on the screen. Okay? So I'm going to draw a circle whose radius is 0.1, right, centered on the coordinates of the point. Right? So I guess I can draw this on the blackboard. So there's your x-axis, there's your y-axis, right? The point is currently here at 0.5 and 0.5, right? And I'm going to draw it as a round circle of radius what do I call it? Big R? Right. And the radius is 0.1. Okay, so that's what we're going to do with this, and then we're going to start to move it around. Okay, this is a little, you haven't seen this yet, right? Final double radius equals 0.1, right? So number 1, so that looks like it's a variable declaration, right? It is. I told you variables should always be in lowercase. It's not, right? It's in all caps, right? And also there's this word final hanging out in the front, right? So a final variable is a variable that you can only assign to once. Okay? So process that for a second. A final variable is a variable that you can only assign to once. Right? If the type of the variable is primitive, which in this case it is, then a final variable is a constant. Right? So here I've defined a constant whose value is 0.1. When you define a constant, that's when you're allowed to, or that's when you should write the variable name in all caps. Okay? So that's what that line is doing. Right? So in other words, I never want to change the radius of the circle that I'm drawing. Okay, dx, 0.1. So that's 0.01. That's how far I'm going to move the point at every step that I move it. Right? So I'm going to start moving it back and forth, right, left and right. I'm going to move it by an amount 0.01. Okay, and now I've got a loop. So you haven't seen a while loop either in Java, right? But a while loop runs as long as the condition inside the round brackets is true. This says while true, so this loop runs forever, right? Right, so the stuff inside the body is just going to keep on running over and over and over again, right? Until I do something to stop the program. Okay, what do? So I take the current location of that point, the x-coordinate, right? So p dot x, what is the current x-coordinate of the point? And I add dx to it, right? So in other words, I move it by 0.01, right? And now I check, right? When I move that point, does it go off the right-hand side of the screen? So the right-hand side of the screen is x equals 1. Right? So does it go off the right-hand side of the screen? Well, I have to take into account the radius. So if x is greater than 1 minus the radius, right, I don't want to move it off the screen, right? I want to stop it on the right-hand side of the screen. So x is just equal to 1 minus the radius. And now I'm going to reverse the direction that it's moving in, right? So right now it's moving to the right, but when I make dx equal minus dx, it's going to go left, right? Because I'm going to add a negative amount to the x-coordinate, right? If I'm moving left, right, then I have to check, well, is it going off the left-hand side of the screen? Right, the left-hand side of the screen is x equals 1, so I have to take into account the radius, right? So if x is less than the radius, right, I'm just going to set the x-coordinate equal to the radius, right? In other words, I'm going to stop it at the left-hand side of the screen, and then I'm going to reverse it. Then I'm going to reverse its direction, right? Because dx in this case is negative, so now I'm going to make it positive. Right? And then I'm going to set the coordinates of the point, right, to the new value of x. And then I'm going to draw it. So there's this class that's distributed with the notes, right, called standard draw. It's not a class I wrote. It's actually a class that's written by some computing science people at at Princeton. Right? Standard draw, it's got a bunch of methods that let you easily draw things to the screen, to a window, right? So the way you use it is you clear the screen, you draw your circle, and then you tell it to show the circle for a fixed period of time. Right? That's 15 milliseconds. Right? So then the loop runs again, right? Moves the point, draws the point, and so on and so on and so on. And what you get when I probably have to stop PowerPoint for this. So what it looks like is this. Hopefully this works. I'm sure the Java, there you go. I just don't know if it'll show it to you on the screen. So this is all it does, right? It just bounces back and forth on the screen, left and right, right? And you can imagine modifying this program, right, so that the point moves in some other direction, right? So if you make it move up and to the right, you can imagine it moving up and to the right and then bouncing around on the screen, right? You put two little blocks that also some player can control, and then you've got Pong, the video game, right? You put some blocks at the top and the slider bar at the bottom, then you've got Breakout, the video game, and then so on and so on and so on, right? Oh, is that going to, okay, right? So there's a simple little program, right? It's not very hard, it's not very difficult to understand what's going on, right? But it produces an interesting result. Yeah?
Would something like this be like, for instance, back in the day on like older TVs, you'd see like the little thing bouncing around?
Yeah, so there's
It'd be something pretty similar.
pretty similar. I mean, there was a video game called Pong. I don't know if you've seen it, right? They built an entire video game console around it, right? The Atari? Yeah. They were all like this. Yeah, they weren't very complicated. The amount of memory on those machines were like tiny. So the programs they were running were not very sophisticated, right? But you can do it in, a few lines of Java. Okay, so like I said, you can imagine more sophisticated examples, right? If you go around poking in the notes, there's a class called bouncing ball that makes the ball bounce up and down. It stays inside the screen and so on and so forth. And so you can run that if you're interested. Okay, so here's an example using the scanner where I'm going to read input from the user, right? So what do? I make a scanner, right? I want to read input from the keyboard, so I hook it up to system.in, right? And now I just, this one is going to read input forever, right? So there's this method called hasNextLine in the scanner class, right? That returns true if there's another line to read, in this case from the keyboard, right? Now it turns out that hasNextLine always returns true if you hook it up to the keyboard, right? So this is just going to sit forever asking you to waiting for you to type something in. Right? Next line gives you the line of text that the user last entered, and when they pressed, so when they typed in and press enter, so it gives you back that last line. And here I'm just going to echo back the line to the caller. Right? So let's take a look at that. So here's the scanner example. Right, so we run that. So nothing gets output, right? So it's just sitting here waiting for you to type something in, right? So now you type something in. So I've typed in hello, and you press enter, and it just echoes back, you entered hello, right? So you type in something else. This is neat. Right, so you type in like this is neat, and it spits out this is neat, and then you say, well, how do I stop this thing? Right, and it echoes back, how do I stop this thing? And it turns out you can't easily stop this thing, right? So there's nothing I can type that'll stop this thing. So that's when you hit that red button there, right, to kill it, and there it is. So now it stops. Right, so that program just loops forever. It's easy to fix. Right, the way you fix it is you define some sort of phrase that'll cause it to stop. So here I'm just going to use the word quit to indicate that you should quit. Right, now I just check the line every time. Right, if the line equals quit, then I stop. How do I stop? Well, I break out of the loop. Right, and that's it. Right, so, yep. Yeah, it'd be similar to input. Yeah. Similar, not exactly the same, but it's similar. Yeah. Right. So that's how you use that's a simple example of how to use a scanner. Okay, now the question is how do you know how to do all this sort of thing without someone telling you? Right? And so the answer is Java documents everything. Right? It was the I'm pretty sure it's the first language that made its documentation easily available to everyone. Right? And so when Java came out, all of their documentation was published on the web. Right? So there's a web page, and there's a standard. It also standardized the format for its documentation. Right? So whenever you read whenever you go to look up the documentation for a Java class, right? As long as the people who created the class were diligent in writing their documentation, it always looks the same, right? In other words, you can read any Java documentation document, right? And it should always look the same, right? So the classes are documented by something called their API, right? API is just application programming interface, right? The Java standard library classes, they live in a standard place online, right? That's the link to the Java version 8 classes, right? It's a similar link for, is it a similar? No. Anything past 8, the link changes is slightly different because of they reorganize some stuff. No, so you can always get to the documentation using a link like that, right? Alternatively, you just use your search engine, right? You type in Java class, name of the class, version of Java that you're interested in, and that almost always pops back the documentation for the class with the first result. Now the notebook classes, they're all documented in their Eclipse project under the doc folder. So let's take a look at that. Right. So in the Package Explorer, you'll see this directory, this folder called doc over here. If you open that up, you'll see a bazillion files. And if you click on index, you can get a web browser in Eclipse that takes you to, let's do this, all class. Oh, hang on. Oh, wait. I have an old version of this. Hang on just a second. Package. Oh, you know what? I think I have a, hang on, let me quickly look what's going on here. You guys should have everything here, and that index should take, oh no, it's all here. Sorry. All packages, that's better. Oh, hey, look at that. Mine's all, this is all messed up. I'm gonna have to regenerate the documentation for you guys and repost a new link. This isn't what I was expecting. There should be files in all of these folders. No, it's here. What do I want to look at? Let's look at point 2. And then I'll try to figure out what's going on with the indexing. I want to do basics, geometry, point 2. There we go. So here's the documentation for the point 2 class, right? There is a notebook that describes how to do this, and there's a video that walks through this as well, right? So when you open up a documentation page for a Java class, it looks something like this, right? Depending on which version of Java you're using, it may change slightly, right? Up at the top, right, it tells you what package this class lives in, right? So you know where to import this class from. It tells you the name of the class, right? This part here is interesting, but we aren't ready to talk about that yet, right? And then it starts to describe what the class is. It starts to describe what the class is supposed to be used for, right? So here, it tells you point 2 is just a point in 2 dimensions having real coordinates, right? And now if you keep on scrolling, it tells you what constructors are in the class, right? So the point 2, the no argument constructor, it tells you to initialize the elements of this point to 0, 0, right? Notice that it's a link, so you can actually click on it. Up here, this is what's called the brief description, right? So it's the summary description. In other words, it's a one sentence line that tells you what the constructor does. But if you click on it, it takes you to the detailed documentation. Right? Now, the no argument constructor is not very sophisticated, so there's not a lot of documentation here. Right? But the other ones, the second one, there's a little more information here. Right? So the second constructor, the documentation says it initializes the coordinates of the point to x, y, right? Where x and y are specified by the caller. And in a Java documentation document, right, the parameters for any method or constructor, they're always documented. Right? So it tells you that first parameter x, that's supposed to be the x value of the point. And that parameter y, that's supposed to be the y value of the point. Right? Copy constructor is similar. Right? It tells you, right, the name of the constructor, the type of the parameter, right, what the constructor does, and what the parameter is supposed to be used for. Okay, it's got a bunch of methods in it too. So if you look, go back up to the top and look at the method summary. Right, in alphabetical order, it will list out the methods. Right, it tells you in the left-hand column what does the method return. In the middle column, it tells you what is the method signature. Right, in other words, what is its name and what parameters does it have. And then it gives you a one-line description of what the method does. Right, and notice this class does quite a lot. Right. The only methods that we use are the ones down at the bottom, but you can see it's capable of a whole lot more. Right? If you click on a method, right, that tells you that that method x that takes in a double value x, right, sets the x coordinate of to the specified value. It also tells you it returns a reference to the point, which is interesting, but we'll leave that for now. Right? And so what you need to do to learn how to use all of these Java classes is you have to start getting used to reading the documentation for these classes. Right? So all the notebook classes, they're all documented here. I don't know why that first link's not working. I'll have to figure out what's going on there. But they're all in here. Right? You can find the documentation for every single one of them. For the Java standard library classes, if you look in the Java standard library, it's enormous. Right? So it's unless you know where stuff is, it's hard to figure out it's hard to find the documentation for a class. Almost everything that we do in this course, you'll find the documentation in either java.lang. Let me pull up the Java 8. Okay, so just give me a second here. So Java 8, and let's look up string. Right, notice the first link, that's actually the documentation for the string class. Right, let's see. One of these will give me the, I want frames, here we go. Okay, so if you turn on frames, you can get a listing of every class that's in the library here. The one up here is a little more useful. So this tells you all the packages. Almost everything that we use is in either java.lang. Right, so if I click on java.lang, you'll get the listing of all of the stuff in that package. And in java.util. So if I click on that package, you'll get the listing of all the stuff in that package down here. Right? If we quickly look at the string class, right, you'll see that the class is enormous. So it has something like a dozen constructors. And I'm just going to quickly scroll through all the methods. Right? It's got several dozen methods. Right? You have to get used to reading these documents in order to learn how to use the Java classes. Right? When you're programming in Eclipse, Eclipse knows about the Java standard classes. So when you're programming in Eclipse, you can actually access the documentation directly from the editor. Right? You just hover over, you just write something like s dot for a string reference, and then Eclipse will pop up the documentation for the string class. Yeah? Sorry? How do I? Oh, you mean, where's Eclipse? Here? Are you asking about the documentation or about the classes themselves? How do I get the doc? So if you, do you have all of the classes? So that's the, those are the, these are, that's the, there's a project that has all of the source code for the notebooks. If you have, no, so they're in Eclipse. So in that Jupyter notebook directory, there's a file called, I forget what it's called, something 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 project.zip. If you import that into Eclipse, you'll get all of that. Okay, but it is there. What time is it? Okay. I'm going to stop there. I think that's a good place to stop, because otherwise I'm going to get like 2 slides in, and then I'm just going to have to review it next class anyway. All right, so that's it for today.